Okay, so you guys have been using this, the WebEx, you're probably veterans of this by the end of the thing, right? WebEx Teams for questions. It'll be up afterwards. If you get back to, your real lives and you have a question, this will still be up there for a while. So I think it's 30 days or something. But then you can still keep asking questions, right? Fill out the surveys, right? We live and die on your surveys. We love when you do the surveys, right? 5 is good, 1 is bad. Just sometimes people know the other way around. I think it's the other way around. We endeavor to make sure that you guys go for 5s, and that if you have a question, this is interactive, right? So ask questions at any time that you want. We can go down a road that you like. If you have further questions, I want you guys to get out of it what you expected, and if we didn't show what you're expecting up in here, then just ask and we'll make sure you get what you expected, okay? So we're gonna go over the introduction of blockchain and market opportunities that we'll go over. Some of the key reference models and architectures that are along with blockchain and IoT. There's like two things are coming up. It's IoT and blockchain, and they're kind of coming together. In the strategic organization, we see 3 things kind of coming together in the future, if we could foretell the future. 5G, IoT, and blockchain. I feel like those 3 are not just trends. They're going to combine into like IoT devices all over the place, and then how are we going to make sure that these things are actually what they say they are, and they're behaving in the way that they should be behaving. So we'll go over the reference architectures. We'll talk about the Trusted IoT Alliance. The Trusted IoT Alliance is an alliance that we helped to form and that we're a part of. In typical Cisco style, when we come up with a new technology, we like to get a group of people together, a group of companies that are working on something very specific, and then take it to the standards. One of the things that you might know at Cisco, we really don't think that you can do something on your own. We're not like the Schmoogles and Facebooks kind of companies out there, right? That are like, well, build something and then we'll do it all on our own academy. You can't do IP telephony unless we all work together, even with our competitors, right? So same thing's going to happen with blockchain. Same thing's going to happen with IoT, right? We know we're going to have to work on. The internet doesn't work if we don't share. Okay, so we'll go over why we do the alliances. Then we'll go over a bunch of use cases and a demo. And a demo at the end. Okay, so that's it. That's
we didn't plan for the demo, but we want to do it a little bit of a surprise. I'm going to show you a real life blockchain.
Yeah, so, a real-life blockchain demo in progress.
Okay, all right, perfect. So I'll start with just a quick overview. Again, it's a really like 30,000 feet view about blockchain, so please ask questions. How many of you have experience with a blockchain? All right, not that many.
What about Bitcoin? How many people know what Bitcoin is? All right, everybody knows what Bitcoin is.
Okay, everybody knows that
everything
part.
you know about Bitcoin this is not Bitcoin, all right?
But it's very useful.
Yeah, it's useful to know what it is. But this is not.
And I'm sure that many of you know kind of the difference between Bitcoin and blockchain. So although industry did try quite its best to confuse you and mix the two, and sometimes you go to the conference that are called blockchain conference, and the only thing they talk about is cryptocurrency. So a lot of the cryptocurrency activity they were trying to hide behind, which is blockchain. But then the only thing they talk about, but actually it's changed. It changed. I think this year, so obviously you have seen what happened with the Bitcoin, with cryptocurrencies. So there's a lot of interest towards not only cryptocurrency use of this technology, but also for something which is practical and something I'm going to share with you, something that the businesses and enterprises started to use. But anyway, let's start with this blockchain. I think I've been asked many times the question like, how do you in a simple language define what is blockchain? And I think in a simple way, sometimes we will say this is pretty much it's a decentralized database. It's an amend-only decentralized database. Just at a very simple principles to think about that. Okay, it can be really fancy language there and so forth, but just this is what it is in essence. So. Yeah, and it's amend-only, so the histories are there, so you have all kind of immutable part of the blockchain is a really important property of that database. Want to talk a little bit about there are different kinds of the blockchain. I think this is where kind of to give you that sense between the Bitcoins and kind of the rest of the industry. So there are 2 important properties when we talk about categories of the blockchain. One is permissioned or permissionless blockchains, and the other one is public or private, right? So these are kind of those categories. So obviously you're familiar with the databases, so that's on that side, and then I'm kind of trying to move through this, and I'm going to talk about those categories. I mean, if you can see, there are 4 permutations. They're free listed here. There's another one, but it's very rarely used. So let's start with this side, from this side, which is probably the most decentralized way and something that you're more familiar with, which is called permissionless and a public at the same time. So these are the blockchains that are permissionless, means that anyone can join this blockchain network. So like Bitcoin, Ethereum, you just go, you download the code, and you can join the network, anyone. And the whole philosophy of the design that like it's designed for anyone to join. And the more participants, the better, and so forth and so forth, right? And it's also public. So the basic philosophy of this blockchain that anyone can see what's on it. So we all can see what's on it, and we can verify, and so forth. So that's kind of the basic principles of this blockchain. In order to keep integrity of this blockchain, they have process that is kind of called mining, which is in essence is solving a complex crypto puzzles. And then for those who solve these puzzles, who get award and so forth. So I'm not going to go into that, but there is a principle of mining, which is probably many of you know about. This is a very resource intensive and compute intensive process. Okay. So then moving from those permissionless public, then there is a permissioned public systems. Let me just skip through that. Now I'm going to talk about the permissions private system. So when enterprises start looking into blockchain technology, they liked the idea that, hey, we have something new that allows us to share information between parties, and we can trust sharing this information, and we can trust the technology in sharing this information. But we really don't like the idea that anyone can join, right? In enterprise context, we know the parties that are interacting with us. So if it's a supply chain, I know who are my supply chain partners, right? If it's a shipping, I know who are agencies that are in the shipping party. If it's a healthcare, I know who is working. I don't really need permissionless. And moreover, I don't really like the idea of being public, right? So I want the information to have some kind of protection. There's some level of privacy and confidentiality that should be in those systems. So that's where the space enterprise blockchain is called permissioned and private. So when people say enterprise blockchains, that immediately means it's a private and it's permissioned blockchain networks.
So how many people have done like MySQL databases or Oracle databases or just regular SQL databases or something like that? Okay, not too much. But if you take a database, right, where you have rows and columns, right, and you took one and you made it completely public. You put it on your network and you made it public. And you say, hey, anybody who wants to add anything could just add something to it. You'd be like, like, who's going to go in there? So before you add a row in there, you're going to say, I'm going to put a little bit of order on this thing if it's completely public out there. I'm just going to say, you know what? If you're going to add something to the database, prove to me that you did some work. So do this really long division for a long time, come up with the number that you're going to come up with. Oh, you did the work? Okay, you could add a row to the database, right? So that's how you leave it open and public, right? Because I can say, you want to add to it? And you go right ahead. No, you add some work to this, and then you can add to it. That's how you make it completely public, right? If you had a completely private database, you would be like, I don't care, just anybody adds in there. It's private. You've got to log into the network. I know you, and I'll let you go in there. But what happens when you want to distribute this amongst different people? I want this database to be used by a supplier. I want this database to be used by Cisco and myself. And those three parties, who I all know, and I know them ahead of time, I say, I'm like, you, and you. You three are going to be able to add to this database. I know, I checked you out. You guys are cool. You can add to the database. But you're all disinterested parties, right? Like you've got different concerns. So what I want you to do is to make sure that all of you agree before you add something to the database. That's what's going on in here. That's what blockchain is really doing, right? So
yeah, that's it. Yeah. So covered in a very simple language. So that's pretty much what is enterprise blockchains. In enterprise blockchains, you do not have mining. Okay, that's a very important thing that I want to say. This is one of the most frequent questions that I get. Like further down, we're already at the end of the presentation, and how do you do mining? Okay, there's no mining in enterprise blockchain. Okay, because you know who are your parties. You don't need to deal. You do need mining if you play with, like, it's permission, public, anyone can join. In order to keep integrity of the blockchain, you do need mining. In the enterprise blockchain, there is no mining. Why it's really cool, actually, that you don't have mining in these systems is you can increase performance of the blockchain. Okay, so you're moving from tens of transactions per second, which is more here, to thousands of transactions and over what you're going to see here. Okay, that's kind of the big difference.
Make sense? You guys got it? And then the other thing to know, if you know about databases, is when I add something, when I add information, it's like a row in a spreadsheet, right? I'm adding a row into the database. Before I add the row to the database, you're going to say, you know what? I'm going to assign that row. So if you want to add the row in there, you three are in the blockchain. I'm on the blockchain too. You want to add a row? I let you in. You don't have to mine anything, but sign the row. We're going to sign the row so that we know it's in there. But the other thing we're going to do is every time you add a new row to the bottom, you're going to assign that row to the previous row. Get it? So now it's all signed and all the way back. So you can't break it. If somebody tried to insert something or tried to add it on the end, it's like, oh, you're going to screw up the signatures, right? That's what blockchain is going to do. It's a secure database that we're putting amongst a private network, as opposed to leaving it way out in the public, right? And that's where we're going. So keep that in mind as you're doing it. That's sort of the basics of it, right? You've got interested parties that are going to have their own, that are going to be joining the blockchain. They're all going to be signing the data, signing the rows, and making sure that everything's intact amongst our little group. So we're right here. We've got a blockchain. Sergey, you can have a blockchain amongst you guys. It's a separate blockchain network. That's why they kind of call it a blockchain network. It's a group, right? Make sense? Okay.
Okay, cool. All right, so I think we covered quite a bit of basics. We covered this as well. So this is kind of why do you need blockchains? Again, when you have multiple parties, each of them, we do kind of look into each of those parties where they need to have business interactions. So supply chain actually is a great example. And I'm going to show actually some of the demo of what we have done. The supply chain is a great example of where blockchain clearly makes sense. You have multiple parties that have to interact with one another. But traditionally, historically, each of them has their own ledger, their own databases, their own system that they track and monitor the systems and the asset coming in, coming out through the enterprises. So, and then obviously, as we add blockchain, we're able to sort of interconnect that. And I'm happy to kind of answer other questions as we go through in terms of how we deploy this inside Cisco supply chain and why we kind of decided to pursue this specific route.
Right. So if you think about the supply chain, right? So you got the shipper, you got the warehouse, you've got maybe some regulatory, and you've got the end person over there. So you're the shipper, you're the supplier, you're the end person. Everybody's got their own clipboard on here. It's going, yep, box left, check, right? That's my database. I checked in my database. Now I give it to Sergey. He's gonna go and move it and take the package over to you because you're the supplier, right? He's gonna go on his thing and go, check, I got it. If the thing is gone and we can't find it, everybody, what's on your ledger? What's on your
exactly.
ledger? And we're all going to compare our records in there. That's what we do today around the planet. Everybody's keeping their own records on this thing. It's better if we were in a shared network. Everybody puts the information in the same place, signs it, and we're all looking at the same distributed information, right? That's what the difference is with blockchain. Is whenever you hear like, oh, blockchain's coming, that's what it means. It means that we can get disinterested people together, and we can all share the same records, signed. We know no one's going to mess with it. You have to have permission to get in on it, right? But doing this like, oh, my record, your record, is it good? Is it good?
Right.
It's slow and laborious. I have to call you and fax you. That's the state of the world now, right? Okay.
That's right. Okay, and just the final one on the basics we're talking about, it's a decentralized system. So it's a decentralized data, it's also a decentralized network of nodes. So when we talk about blockchain network, predominantly we talk about network of nodes that are connected together. And that's kind of where we go into details.
And a good point on that is the difference between, like, why would Cisco do blockchain, right? You figure it's like a database kind of thing. It might be a database. You might hear blockchain coming from these bigger companies and stuff that are like doing this. If you take a blockchain network and you store it up on a server, right, and everybody connects to it, what's the point of having we're all logging into the same system. Now you really only have one person who's what we're saying here is I have an information, you have the full copy, you have a full copy, you have a full copy. We all maintain our full copies, and we can all be assured that we all have the same information. I don't have to compare, right? That's something that Cisco does because we get distributed data, right? Like we get distributed nodes. We know how to handle tons and tons of distributed nodes. Other people are like, oh, we could do blockchain. Let's just stick it up in the cloud. That's not how you're going to do this if you're going to try to do shipping around the planet. That's not going to work. Okay? So that's the difference between the approaches, right?
Okay, perfect. I think we agree. You're going to go preview of the next slide.
Oh, sorry, dude.
It's all right. So this is a good logic. So again, you have access to the slides. I have a look into them. From my experience, again, I've been in the blockchain space for quite some time already, and met with a number of startups, number of big enterprises, banks that are coming to us with a variety of the ideas and say, hey, we have this idea and we want to run the blockchain project with you on this idea. And then you're trying to understand this idea more and more, and then you kind of coming, I would say probably in the 70% of the cases, coming to obvious question, do you really need a blockchain for this? This is a really good question to ask. Before you jump into any blockchain project, just try to kind of go through. And one of the most obvious questions, the first question number one, is in terms of that, are we talking about multiple trust boundaries or everything is within one trust domain, right? Running blockchain within one trust domain, within one organization, really doesn't make a lot of sense, okay? There are some circumstances where it may make some sense and people say, hey, it's just for audit. They will come and check as we change or modify some of the records. Maybe we can keep blockchain for that, but the other people can argue that, well, if it's still in your domain, in your control, you can still do something with it anyway. So blockchain makes sense when you talk about multiple trust boundaries. That's just a first clear cut, so that you need to look into. Then you kind of go through the other logics in terms of, are they in a business relationship? Do you need to exchange? Are they really trusting already one to another? So there's one really big company that I can't name publicly, but you can probably guess who is a phone manufacturer. But if you own your supply chain and all the components that are produced there, you own everything. There is really not much value you can get from putting the blockchain over it because in essence, you already have visibility to everything. You control everything and everything is in your in your visibility already today. So in our case, when I go for Cisco, so Cisco, for example, doesn't own a single manufacturing facility, right? So we outsource everything. So we have to rely on other parties, and those parties have to rely on other parties and so forth. So our supply chain can go up to like 12 to 15 tiers deep in terms of people and organizations that have to rely on one another. So in our case, blockchain makes perfect sense. But in organizations, or for example, some companies that make famous watches, where everything is just controlled by one organization. Well, blockchain really doesn't help you to improve anything in supply chain because you already have a lot of the ability to see what's happening there. Make sense? Okay, this is a good question. Please ask this question every time you think about the blockchain use case. Do you really need a blockchain? Okay, I think with this, just the final slides before we jump into the architecture and the whole technical meat is the market opportunity. So we did a couple of studies. So this is just a highlight in terms of is there a business need for blockchain and what kind of things out there that blockchain can help to solve. So here's the numbers out there. We did the same analysis for Cisco. So we also looked into where blockchain can help within Cisco. And there are a number of use cases came our way and probably kind of because we're manufacturing and producing organization, kind of supply chain was clearly kind of standing out. This is where we have a really, really big opportunity. And that's what I'm going to talk about more. I'm going to show you the demo. So, but that's kind of what's out there in the world and kind of things that we can help to solve with the blockchain. So I think, and then finally, these are kind of use cases that popped up. So different industries, some of them are going horizontal, so like supply chain, logistics, different industries that can apply there. There's lots of things happening in the financial sector. There's also a lot of things going on in identity, specifically distributed identities. So again, this space is evolving. It's a very new kind of domain, but there are certain areas within the space that are kind of getting really established, and you can really justify why blockchain, because blockchain clearly can provide something that is no other technology is capable to provide in those areas.
Right, and each one of those, I mean, if you look at the use cases on this compared to your questions that you had on there, you can kind of see that there's multiple parties involved in each one, right? In supply chain, as we said, people manufacturing something and then supplying it. You're going to sign off that you made the component got shipped to you. You're going to say, okay, I got the two components and now I added them together and I boxed them and you shipped it to a logistics person. Then the logistics people are going to say, oh, I got the box, check. You know, it's almost like FedEx or something like that. You know, when you do it, they know where they're in control of the whole thing, right? So they can see it. But if you're trying to do FedEx and you're going to have all different parties in there, well, think about agriculture too. You get something from the farm, and then it goes from the farmer to an area where it's going to be held, to then where it's combined, and it's put on somewhere else. If I'm the farmer, I don't know where the heck anything went up there. Did my stuff get delivered? Was it my fault that something went bad or something like that? And those logistics in those carriers are big. So on the planet scale, these things are there. Finance and trade, you could see what people want to do in the financial, if anybody's in fintech or any financial companies. Shared ledgers are going to help when you're clearing trades. I get a trade from one company to another company. Those are outside bound. They fit very clearly into that disinterested parties, right? Payments, asset trading, KYC requirements.
Sorry, identity.
What are the KYC requirements?
KYC, yeah, know your customer.
Yeah, know your customer requirement. Yeah, so you and your customer could have different relationships and stuff like that as well, right? So, yeah.
All right, perfect. I think with that, let's jump into
Makes sense? Any questions on that?
Yeah,
Sure.
Go ahead.
And it's regarding you guys, Cisco, and what I was hearing previously, that you have your own blockchain, correct? And you use it for tracking your supplies. This is my understanding, correct?
So the question is, do we have our own blockchain and is it used for tracking our own supplies? So we've been, Sergey and team and the blockchain team, are developing our own blockchain platform that we're offering out as a blockchain platform. We eat our own dog food, drink our own champagne. We're using that blockchain, right, to do our own supply chain as well, because it makes total sense. We're not going to build that thing and then not use it on our supply chain. So we did it first. It's very close to what we did when we did IP telephony, right? We did IP telephony and then we put the phones out and then we used them internally, right? Even when the headsets were like, burning. But but so we're using blockchain ourselves. Yep.
Here comes my questions.
Sure. Okay.
Okay, so it's distributed ledger, okay? And when you're running a big blockchain, you manipulate them with smart contracts probably, but not all the parties involved. However, if I'm one of the parties, and I like to have the ledger, the server going to download the blockchain to me, I'm going to download all the data relevant to me or to our transactions or the whole Cisco blockchain. Everything included.
Okay, that's a really good question.
Good question. So probably
Let's
I'll give a quick answer, and then
just-
I'm going to have actually a demo, and I'm also going to have talk about this. I have a slide. So, but
Let's
really
repeat
quick,
the question for the
really good question in terms of the visibility. So how much, if you're part of the blockchain, like even in Cisco supply chain blockchain, will you kind of have everything? You're going to see everything. So do you remember when I was going in terms of the permissionless and private? So private means that you have level of privacy and confidentiality in the blockchain. Okay, and I'm going to zoom in into that. I'm happy to answer, by the way, question. This is a really important topic for the blockchain because a lot of the blockchains are not well built for privacy and confidentiality. So we in our blockchain implementation, we have developed probably the best in the industry way of doing this. It's called selective disclosures that allows you to selectively allocate specific fields that you will have visibility to. So if you're joining the blockchain and you only have to have visibility to those fields and those records, we can assign the rights that you will have only access to those fields on the blockchain. So, but I'm going to show you the demo. I'm going to go for that. So hopefully that will kind of clarify. If not, happy to answer for that. Okay? Yeah. All right. Sure.
How charging side will work? I mean, by downloading once the database or by the update of the database or how many records I'm using from this database?
Okay, so repeat the question and I'll say, yeah, for the recording. So the question is, how many transactions are we going to be stored and how many?
No, the cost side, because some of the slide is presumably cheaper than the other transactions. If I use your database, how you charge me or?
Oh, how are we going to? Oh, how are you going to pay? How are you going to pay? The question is, how are you going to pay? I love this. I can't wait to buy it. How do I pay you? Is what you're saying. Okay, yeah, go ahead. BD guy, answer how you're going to pay.
Well, so this is private enterprise blockchain. That means that it's not kind of public that, hey, Cisco has some public blockchain, you just join and pay some fees to join our blockchain. This is a blockchain network that you will set up in your own environment with your customers on the infrastructure that you will choose to put this blockchain into. You can run blockchain on the cloud, you can run blockchain on the data center, and as well as we are looking forward to talk more about it, how you can run also blockchain on the network. So that's something that we're going to announce in next Cisco Lives. So just going a little bit ahead. But that's kind of where blockchain sits onto. It's your blockchain, you are setting it up. Enterprise blockchains, again, maybe just going a bit more deeper beyond the one-on-one, but enterprise blockchains, you can either start them, there's one model to start them, it's called anchor tenant. So we're one company, so for example, in Cisco supply chain, we're the ones who initiated the blockchain network. So we're the anchor tenants, and then kind of from us, that's where the network started. Okay. There is another model to run enterprise blockchains, which are consortium run. And you can move from anchor tenant to consortium. Consortium means that there are multiple parties that actually control the network. In enterprise network, there's someone who controls the network, because we talk about privacy and confidentiality. Who establishes privacy and confidentiality, right? It's an obvious question that would come, right? So in anchor tenant model, it's a anchor tenant, so in our case it's Cisco, that we establish who has access to which part of the data. In the consortium environments, then it's a consortium that has to agree on who has access to what and establishes the rule of accessing into the blockchain. But to answer your question, kind of this is your infrastructure, kind of you decide how you're going to run it. In terms of pricing, how Cisco is going to sell it, is it going to be priced per node or something? We're still trying to figure out the best way to make it out there. So well, that's where we're going. All right. Let's jump into architectures.
Yeah, that makes sense. I mean, so what you're going to do is, to your question there too, maybe try to put both of them in there. Both of you are going to be on a blockchain. You're going to be in the blockchain, right? You're going to run your blockchain. I'm going to say, oh, here's your blockchain node. You're going to pay a very reasonable price to Cisco for it. It'll be awesome. But it's some licensing fee that will work out, right? Here's the blockchain node. You're going to run it. You decided to run it on your UCS service because you got plenty of space, right? You decide, right there, you're going to say, oh, I'm going to run it on AWS or out in the cloud or something like that because that's how I operate, right? Now, your blockchain nodes hook up. You both have a complete copy of the data, right? But a gentleman back there, you're saying you don't want him to see everything. You only want him to see what he's concerned about, right? So in the consortium, amongst the group of it, we're all going to decide what you can see and what you can't see, the administrative rights on the fields, just like a database, right? You're going to say, you have access to these fields, you have access to these fields, that's it, right?
What he still downloads.
Yes, you have to have the whole thing, yes. You have the whole thing, but he can't see it, it's obfuscated.
One quick caveat to that. There is a feature that we're adding into, which is called zoning.
Yeah.
This is to meet requirements. There are some country and region-specific regulations where the data is not allowed to leave specific region or country.
For GDPR.
Right? For GDPR or other compliance reasons. So you can actually put certain nodes and say they're part of this zone this, and the data will never leave outside of those.
Yeah.
Of those domains.
There's a lot of concerns, especially with GDPR, right, to be forgotten. If somebody comes around and says, oh, both have information in there, right? And now it's the right to be forgotten. I got to pull it out of the blockchain, right? That's something that we did. Nobody does that, right?
Yeah, but what is information still encrypted, so if you try to, open it and you break it, so it means it's valueless.
Right.
It doesn't matter where it resides,
Exactly. So we've made sure that it does the compliance and the stuff. So that's a little different than what we're doing, than other people are doing on the blockchains. That we made it fully distributed, role-based access, GDPR compliant, country compliant, geo compliant as well. Yes.
But you just mentioned that you changed it today, that you can pull data out of the blockchain.
That you can pull data out of the blockchain. So your question is yes.
For the GDPR perspective, we can remove data from the
Now you're going yourself. You see, you open the right hole
Yeah,
into
yeah,
GDPR. So maybe we can talk about GDPR. If you are interested, I can talk.
Yeah, we'll talk about it.
To a little bit.
We can
because
do
it's
that.
It's a very interesting question. How do you do GDPR in the blockchain?
Yeah.
That is supposedly doesn't forget.
Yeah. We've solved
happy
that.
to
We
cover
can do
that. We solved that. Yeah.
That's a level two question on that one. Yeah. But yeah, we can do that. We'll show you this. Yes. Last
Good
question.
question.
how database will be distributed, how will get a copy, is it, what will be the protocol that will transfer the data?
Correct. When you think about blockchain, I think we're gonna show some of the architecture slides in other presentations. There are also like a whole stack. When you talk about blockchain nodes, it's actually a collection of protocols. There are protocols at different levels. There is a database, there is network protocols, there is identity protocols, management protocols. It's just a collection of protocols. So that's what usually when people talk about different blockchain, I would say stacks or projects, it's a stack of protocols. And different organizations have made different choices of what the stack looks like. So in the Cisco blockchain stack, we made choices on how the stack is composed. Inside that stack, we designed multiple of components ourselves because we felt that this has to be done this way. If you look into project from other vendors, you will see similar architecture, but different components that are chosen there. So.
No, it's a good question.
Good question.
Thank you. Yeah, thanks. Okay.
Right.
So part of the focus of this talk is also about IoT and blockchain. So the first thing we had to do is make sure you guys all had a basic understanding of blockchain. Then after that, we have to turn around and say, okay, do you have an understanding of IoT? So how many people are deploying IoT solutions? Okay, kind of. You have a lot of things on your network to begin with. We opened up, as we said, Cisco founded a consortium, another consortium, OpenFog, which started out as a very small group, and now it's quite a large group of different participants in here, to come up with an architecture for IoT, okay? And then, so I'm gonna just give you a brief background on like the IoT architecture, and then I'm gonna explain how IoT and blockchain work together, all right? So I know you hang in there, you're all experts on blockchain now, because you had 2 seconds of it. But the architecture for this is we came out and we said at the bottom level, those are all the things in your network, right? The level above that we call the fog, which is a cool way of doing it, right? You have the cloud all the way on the top and the fog as it comes closer to the bottom, right? As the cloud comes down, it's a fog. So that's what we call, if you hear the term fog computing, that means we're just doing computation closer to the edge. What does that mean? If I have a light switch on the wall over there, right? And I flip it on, you're not gonna go all the way up to the cloud and say, okay, validated, and then come all the way back and turn that light bulb on, right? I mean, you want to do that over here, right? There's some things that are just naturally done in the cloud. Also, if you start to look at video analytics and some of the deep fusion things that we've been doing that Cisco's starting to offer, there's some things you want to do close to the edge on the camera itself, and then some computation that you want to do up in the cloud. You don't want to shoot everything up there. So we realized that there's an architecture where we want to run some things closer to the edge. That's the things, if you start going around, you start seeing us running containers and things in IOX. If you started hearing about that, people are asking us, oh, well, Cisco, you've got your infrastructure in there, and you've naturally set up this hierarchy on your network where you have access points, access level switching and access level for wireless. Why can't I run something over there, right? Instead of like running something in a data center. And more and more we're getting asked to run on our architecture. Because our networking architecture, the campus architecture, is a natural progression of taking things from the bottom, coming up to the edge, then going to a distribution and then the core, right? So it's a natural hierarchy that you're like, oh, I want to run some things here, I want to run some things here, I want to run some things here. That's what we've been doing, and we're like, whoa, slow down on this for a second. Let's come up with an architecture that lays it out very naturally. It says, okay, this is what runs on an endpoint. This is what's appropriate to run in the cloud. This is what runs at the regional level, and then what runs at a higher level. And we wanted to make that organized in a way so that we can have people run that out, okay? Excuse me. So one of the products that we have is Cisco Kinetic. Cisco Kinetic we have offerings in that architecture that allows you to take data from an endpoint, bring it into maybe a gateway. It could run on your gateway routers, on your routers like the 800 series or the 1000 series. It's a very natural progression point to say, ooh, you know what, let me let that router work as a gateway for information that's coming in. So I might have a temperature sensor, and I want information to come up. The information is going to come up there, but I want to change the protocols and tag things and take a look at it. Maybe I got a sensor that's saying, this is the temperature, it's 10 degrees, 10 degrees, 10 degrees, 10 degrees, 10 degrees. I don't need all that information going up to the cloud. Maybe I want to aggregate the average for a little while, and I want to dump a lot of that information at the edge, right? Or maybe we have a sensor in the room that says, no one's in the room, 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 no one's in the room. Somebody walks in, someone's in the room. Like, all that no one's in the room, I don't care about, right? So you want to filter these things down. But then every device is speaking a different protocol. Back in the buildings, BACnet, Modbus, right? And now you've got, well, I want to translate them into maybe a normalized format. When do I translate it? Do I translate the edge? Do I wait till I get all the way up in the cloud and then run some AI on it and then do it? No. You want to put that in a progression and have that there. So Kinetic will let you do that so that the endpoints can then find a place to rest on our network hardware, and at that point we can aggregate things up and start to give you a natural aggregation point. And MQTT has been coming out to be one of the biggest gateway protocols that is being used for this. MQTT is a publish and subscribe mechanism for putting events out for IoT, and that's the one that keeps going. There's other protocols out there like CoAP and things like that. We can do translations to from these protocols and data formats. And think about the data formats. Fahrenheit, 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 Celsius, 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 right? I mean, annoying things like that have to get normalized, right? So, I mean, and that was just temperature. Imagine when we get into like something that's beyond that, right? You have to aggregate the data first by the protocol that you're speaking, and then also by the format of it, right? Somebody said Fahrenheit, Fahrenheit, Fahrenheit in binary, Celsius, Celsius, Celsius text, right? You know, so that's what we're trying to do, and we're trying to have a normalization architecture for this. So what can we do with blockchain on this? Well, I have a device over there, and it's sending out information. Temperature, 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 temperature. What we've done is we said, oh, let's take that information, let's tag it as it comes directly from the device, because we're the first person to pick it up, our device is the first person to get something from the edge. We'll take it, tag it, store it in a blockchain. Now, all the way later on the top of that stack, if somebody wants to go and validate that information, you know, I got a temperature reading from this actuator on an oil rig, right? That doesn't look right. Let me go check it in the blockchain and see if that actually happened. Oh, wow, it's signed, it's exactly the same. So what we're doing on the edge is we're taking the IoT information, we're starting to tag it and store it in the blockchain so that later you can go and check and see if the information was correct, has it been tampered with, things like that. That's what we've been trying to do with blockchain. So we're still trying to feel a way around, but we talked about using blockchain for supply chain, and that's really at the application level. Now we're starting to say, well, what can we do with networking information, right? We got our hands on it. What can we do? And that's what we're starting to think about, is like, how do we tell what a device can do at the edge? Yes, question back.
So the blockchain is, keeping, all the information together.
Yes.
How it's temperature collecting and putting it in the blockchain, it says it's going to reside forever.
Sure.
Do you need any information at all, or is there any mechanism that you can dump off for production? Let's say, 10 years ago it was 10 Celsius degrees here, so I don't care about that.
Right.
Yeah.
Right.
Critical data. When do you pick it up?
So the question is, wow, you're generating a ton of data. Why don't I just get rid of some of the data that I don't need and it's old and it's on retention? And that's what we used to say. It's like, yeah, we'll clip things off and get rid of it. In the world that we're living in now, data is oil. It's the most important thing in there. And that it used to be really expensive to keep that information, but now it's starting to get to the point where, you know what, that information is going to get offloaded, right, and not tossed, because you need that for training, for AI and ML. So remember I talked about it's the convergence of these things? So actually you want all that weighted information, the fact that I said temperature. I kind of made it like it was useless, but in the case of retention and archiving, you're going to move it, but you're not going to get rid of it, because you want that for training, you want that for historical data. We would actually pay for a lot of that information and get it for the training, the way that the world's going. So that used to be the way we were thinking. We kind of moved on and said, no, I want to keep it. If you're storing it on your own, yes, you're going to have ways to archive it and delete it off. So we'll still give you the features to do that, but I got to just say, practically right now, nobody's doing that. Everybody's keeping it. It's in there. So, but really good question, yeah. So the kinetic architecture is our IoT architecture for extracting the data, making computational data, moving the data from maybe a local store to a historian. And I always like to say the DVR or the TiVo model is really good, because that's really what everybody does with their data, right? You got live, you've got immediately in the past half hour, and then you've got stored, the things, the programs that you're storing it. So you're either watching Game of Thrones live, you're pausing it just looking at the last half hour, or you've got the whole collection of it in the background. That's really what everybody does with their data now. Here's the live data, here's the local restore, there's the long-term data, and what are you going to do with the long-term data? We're going to start mining that, right? And Kinetic is the platform for that, and we're seeing the merger of the two, and is to try to say, blockchain can tag this and give information in there so that we can look at it and go, I can trust the information in there. We're still having a hard time figuring out if somebody compromised it in between the first hop, right? So the temperature information comes to me first at the switch, and I'm like, I got it. Was that really you? Did somebody tamper on that first hop? That's the part that we're still secure. There's tons of ways that we have of securing that, right? It's .1x. There's a ton of things that we could do with that, and I'll start to talk about how we get that. So it comes into securing the IoT messaging, and that's something that we did. The World of Solution is closed now, but we were showing this as a demo in the innovation area, where we can say we want to check the provenance of the data, where the data came from. We want to check the integrity, and then also go back message recovery in case it was lost in transit. So the blockchain information that we can put out really helps us with all three of those problems that you have in IoT. Okay. So what happens is the IoT message comes in. We'll tag it as soon as we get it in. We'll do an outer hash on that thing and start to compute that and put it into the blockchain. We'll sign it, and then we'll start to bring it and put it up into blockchain. So I'm not going to get too deep into how we do the blockchain. I can give the information to you in a blockchain node and say, go ahead, figure it out and start hashing it. Or I can go around and use the power of the network. The best thing that I always like to say on the power of networking is, are you wearing black socks? Are you wearing black socks? Okay, are you wearing black socks? Are you wearing black socks? No. Are you wearing black socks? I mean, I can go around and poll one at a time, but it's a lot easier to go, who's wearing black socks? You're going to raise your hand, right? I want parallelism, right? It's a lot easier for me to do. Like this is a lot of computation time for me to go around in all the nodes. But if you actually start running these things on the switches and stuff, we own the infrastructure, right? If things are computed in transit all the way up, I get a lot more computation and I could do a lot more, right? So that's what we've been trying to do with the blockchain and why we can do a better solution. In that I don't have to throw everything up in the cloud and compute it, right? No, we're going to do it along in route, right? So that means we can scale up. The stuff that we've been doing is we can do well over 2,000 requests a second in the node. So if I give you a blockchain node in there, you're kicking butt doing 2,000 requests in a second. But even if we did a small number of just say like 50 in a second, if you start to look at the multipliers in there for the network effect of the hierarchy, we have a lot of distributed compute. And if we do it in flight on the way up, we can do a lot. We can do 2 million messages at that same time. We get the exponential growth on that if we do that. So that's the kind of things that we get to do because we're not distributed, okay? That's why we feel like there's a good handle on this where we could say we can handle IoT devices. First time people start looking at us, they're like, you're going to take all the IoT messages and you're going to throw it into a blockchain? Good luck with that, right? And we're like, what do you mean good luck with that? We can do it, right? So, but if you think about it as storing everything to one node, to one workstation, you'd be like, it's going to kill it. Throw it in the cloud, you're going to kill it, right? Not us. We're going to do it in flight, right? So that's what we're looking towards. Okay. So, the other thing is, yeah, question. Yeah, so the question is, the router's going to look at everything in routing, and I want my router to keep doing routing. I don't want my router to do that. Yeah, no. Right. This is not, the stuff in here is not built into the routing, into the data plane of it. What we do is we can run a container on the second cores and on the second compute. So we're adding more compute onto the devices. If you take a look at our 9Ks, our Cat 9Ks, they have the ability to run straight compute along the side, and then that thing is going to start to do the compute on there. Yeah. So good question. Yes, you need to install something. Yes, you need to install something. Yes. So the last thing in there is like identity. Starting to look at things. All right, you are a light bulb. Okay. You are going to tell me when you're on and when you're off and when you're dimmed, right? That's probably what you're going to do. All of a sudden, you start sending me temperature readings. That doesn't look right. Or you start going, I'm on, I'm off, I'm on, I'm off. It's like I need to know the behavior of a thing in order to know if you're real or if you're the thing that I expect on it. So what we came up with in these consortiums is MUD, Manufacturer Usage Description, okay? The manufacturer should describe to me what protocol, what it's doing, what ports, and tell me exactly what this thing is doing so you guys can shape the traffic, you can put in your firewall policies, because that's one of the biggest problems that we think that you guys are going to get out there when you put these IoT devices on there. I plug it in the network, and I don't know what this thing does, and you have to learn it. Tell us what it is, right? So what we do is what we're saying is there should be a description of a device, and the manufacturer should put that. That should be in a repository somewhere so that when a device comes on the network, I can say, oh, what are you? Hold on a second. Let me go check what I think you're going to be. Thank you very much, Bob. You are a light bulb. Bob is a light bulb. And I got Bob as a light bulb stored, and I'm going to make sure Bob is behaving like a light bulb all the time. When second Bob starts to behave like a workstation, that's not cool. Okay, so that's the kind of thing that MUD is going to let us do. So we'll look at the .1x first to make sure. Oh, Bob, log in, Bob. Right? Oh, Bob, you're a light bulb. That's really good, right? That's what we want to do. After that, the MUD controller will go out and get the information and say, okay, what's the manufacturer usage description on that? What we're saying is that manufacturer usage descriptor you have to trust, and that's going to be from multiple parties, right? What's good use of blockchain? Multiple parties that are going to go in and put in all of these descriptors. If somebody wants to add a descriptor to a server, it should be in a blockchain, right? And saying that, oh, I see, oh, it was changed, right? I got an upgrade to the light bulb, right? So that means I got to know that that change was agreed upon by everybody and it was stored in there. So that's why we could secure that with blockchain and see the history of that configuration as well. Excuse me. So if I go back in time and I see, oh, this is Bob, but Bob's running a previous release, I could say, oh, okay, back then he was supposed to run like this, now he runs like this, I could see the history of it, right? So that's what blockchain is going to give us when it comes down to the usage descriptor. How are we going to, yes, question?
Do laptops and other stuff, will they be using MUD descriptors as well?
The question is, will very complicated devices that can behave like anything else and mimic anything else, give me a descriptor? It's not designed for that. You could, right? But it's a lot harder because the nature of the endpoint is that I can make that thing look like anything, right? So the idea would be if you logged in as a .1x profile, we could probably do it at a .1x profile and say what you're doing, but I don't think it would be a manufacturer usage descriptor. It'd be more of a user descriptor when you get there, because you know, a workstation is very user specific, not very device specific. Right? A printer is not. That's true, right?
Yeah, potentially printers, yeah. That's the...
Yeah, there is this little bit of art in there, in that we were looking at manufacturer usage descriptor for small devices, for devices that didn't have compute, that doesn't have a lot of compute resources, because the device could tell me what it is and come with its own descriptor. That's a driver, right? But we're looking at like a light bulb where I've got like, you know, K worth of processing speed and stuff. It's not going to be storing the descriptor, so we're going to put it somewhere else. So you could, but it's not really designed like that. Yes, another question.
Now we're looking at program on a network. Is it going Python to work for this blockchain, or will it be something else that we use to service data?
The question was, are we going to use Python to access for the blockchain? I mean, we're going to be open to whatever programming language you're going to interface with. I mean, or you're asking what we're going to code it in.
Yeah, is there anything defining anything there? Because right now, I mean, even here in Cisco Live, we want to try to piece and
Right.
use Python for our network, start programming our network.
Right.
Well, so the question is, should I be looking at Python in the blockchain? I mean, it makes Python as a scripting, we're getting off topic, but I mean, Python as a scripting language is a lot easier for you to deal with. I think we think the reason we're pushing that in DevNet and that is because we think, and we know you guys, we know the user base here. I'm not going to tell you to go to Bjorn Strausstrup and start writing C++ and something really weird and cryptic, right? It's just a lot easier. So the answer is, you don't need it, but yeah, go for it. That's the trend, is everything going towards Python.
Just maybe to give you a preview, say in the Cisco blockchain, the smart contract language that we first enabled is JavaScript.
Cool.
Because we believe that that's the biggest community of developers will appreciate that, but we also will add other languages, but JavaScript is the first language.
Oh, question is that, thank you very much for the question, if I wasn't clear. The question was, is the MUD controller running on the device or the switch, or is it, the MUD controller is like a service, so think of it like a DNS, right? It's like a DNS server running somewhere, and we're saying, hey, go out there, give me the descriptor and come back. Like a DNS server is going to tell you, hey, where are you? This is going to say, what are you, right? That's what, and this is a protocol that's going in through the IETF the same way as DNS actually is, and that's a distinction at the thing, where you are, what you are. That's a distinction that we're doing philosophically. So then let's go wrap up some of this stuff. But one of the things is we're building this into ICE, right? Is anybody running ICE for entry code? Yes. The next release that's coming out will support MUD as well. So when your device comes in and you're going to give an entry in there, that's where you're going to be able to put it on there. So when the light bulb comes on the network, it's going to go through ICE, it's going to get the controller, and we're going to do all that stuff. So we're taking that protocol and building it in. Okay? Again, that's where we want to lock that up with blockchain when it brings it in there. Okay? Trusted IoT Alliance. I'm doing that one. The Trusted IoT Alliance. Trusted IoT Alliance is a consortium that we founded in order to take the concerns about blockchain and IoT and start to put it together so that we can get these things worked out, right? We're working it out as a consortium, and you can see the list of companies there, and Bosch, Cisco, Foxconn, and some of the blockchain companies as well. We're trying to work all this out and come up with an architecture. Just like we said IoT should be in an architecture, and that, look, where you're going to run something, we should all agree on where things run. We have to do the same thing for blockchain. The industries that will benefit from the consortium there's tons of them. I mean, so it's the same thing in IoT or anything like that. All these different industries are participating in the consortium. And like any consortium or any kind of a standards group, there's things that the group is going to come out with. So it's going to be a reference architecture, protocol references, the patterns of use. People will say, okay, well, this is the way we see devices using in supply chain. This is how we see it in building management. And then we'll say, oh, how are you going to do your asset life cycle as well? How are you going to trust the life cycle of a project? And we'll get into the demo in there. The reference architecture is going to be along the lines of saying, okay, I have some asset in the field or something like that, and then the blockchain is going to communicate with it exactly as I just described.
Yeah. This is just on the previous slide. Sure. I think this is what currently is being discussed in terms of where blockchain sits architecture-wise. So either it sits behind the IoT clouds, so that's just one option. Then as you can see, the other option is something that we're going to enable, that's the blockchain client can actually run on a gateway. So like on a 29 IR device and immediately I'm going to talk about that use case. Or also where we're working on is, can we blockchain enable the assets? So the asset can be natively supporting blockchain. So clearly for the legacy assets, the gateway is preferred way. For the new assets that are coming in, we're looking into how we can blockchain enable those assets.
Yeah. So if you see there's this merger of IoT and blockchain, right? So IoT's got this endpoint access, the core, so you get the choice of where you're going to run the blockchain, and we have to think about it. If everybody runs it at the bottom, it's going to change the way the whole internet's working, right? If everybody runs at the top, well, now everybody's going up into the cloud. We want to go out and say, okay, let's get together and agree. These are the type of things that run down here. These are the type of things that should run over here, right? Makes sense? Okay. And what that does then is allows us to build what we're talking about is an internet scale trust. I talked about this group over here having a blockchain, and then that group over there having their own blockchain. What if you want to take something from this blockchain and move it into that blockchain? Sounds like a router, doesn't it? So this is the kind of thing that we understand. If you're going to have these chains of information and you want to route between them, it's going to wind up building up close to what we do on the internet, right? Okay, so supply chain.
Perfect, yep, thank you.
And then we're going to do a demo, so we want to get you to demo as well.
All right, so I'm going to start with a supply chain counterfeit use case. And that's exactly what we're going to show you the demo. I think we talked enough already about supply chain, so hopefully you get a good feel that this is the right environment for the blockchain. So, and I think what I would like to share is more of what we did within Cisco. So we, from a Cisco perspective, our supply chain is not doing too bad. So Gartner recognizes us as a number 3, the world's most efficient supply chain organization. So I think Unilever is number 1, and then I think someone is number 2, and then we're number 3. So we're doing pretty good job. But at the same time, when our supply chain team have seen the blockchain is coming, they were like overexcited and trying to look into, well, what this technology can do and what are the use cases. And we identified 52 use cases that we can apply blockchain technology that can solve real business problems for Cisco supply chain. And then from those 52 use cases, what we did is we prioritized the ones that have the highest impact, but also the ones that are relatively easy to implement. And the first use case that we went into and something that we implemented, and I'm going to show you the live demo of that, is the use case related to those things. Do you know what is
yeah, that's a good question. What is the #1 counterfeited
this is a
Cisco
live
product?
question. As SFPs, correct. So SFPs actually is one of the most counterfeited products that we have. Very well counterfeited. By the way, when we're going to do the demo finish, I welcome you to come over and have a look. One of those modules, I'm not going to show, I will show for the demo actually, which one is, but you will have a look. Is real counterfeit, the other one is a real product. And the whole point of this demo, when we're giving this in your hands, is just like, there's no way visually you can find out what's the difference. So that's kind of where we went. So, and we feel the pain of having this counterfeit, predominantly that our customers like yourselves, at some point of time finding out, hey, I paid a Cisco, I expected it to behave like a Cisco brand, and then suddenly this module starts to behave really, really badly. And probably as many of you know, when this module starts to behave badly, it's not like on-off. It's actually sometimes it's kind of goes and it's working and it's not working, and then you're starting to do troubleshooting and you're looking at IP, is it a data layer, is it a physical, if it's a physical, what? And coming out to conclusion that this is a module is counterfeited, it's a pretty tough job to came to that conclusion. And when you came to that conclusion, you say it's a counterfeited Cisco, I'll give it back to Cisco to replace. You're giving it to us, we're on the checks to some time and kind of doesn't look like it's our module, okay? And then what's gonna happen, so inside Cisco we have a group called brand protection that will actually say, okay, now we'll start investigation. So because you're saying that you bought it from our partner, you're believing this is a Cisco, original Cisco modules, and then we start investigation. And it's going to take us on average about 7 to 8 weeks to run for investigation, check all the ledgers and so forth, until we find out where potentially was the source where this may have been introduced into our supply chain or into our channel partner network, right? And then kind of working with law enforcement authorities to find out where actually it happened. So it's quite a lot of time. I'm going to show you in the demo how I can do and achieve this in just a matter of seconds to find out what's going on. So that's kind of blockchain, really cool, and that's how it applies. So counterfeit is, you can hear a lot about counterfeit in other industries. It's kind of one of the top use cases that the supply chain industry is going into. Next use case is the healthcare use case. The reason why it's slightly different use case from an IoT perspective is that here, and we're working with a couple of customers that are interested in this use case on a proof of concept. The question that we've been asked is, how can I trust So this is a beautiful use case. This is a blood, so you're transporting the blood over your supply chain, over some transportation facilities and so forth. How can you ensure that not at any point of time there was a temperature change which went outside of the established regulated boundaries? So it wasn't never too hot or too cold. Because if that happens, right, that pretty much that may have an impact on the blood itself.
And
so you want to have that assured transportation.
And blood is one use case. I mean, we did another use case in Asia for mother's milk, which would spoil, and where people donate mother's milk, and we do that. Also, anything like food processing, things like that, we want to ensure the bounds of that. Yeah.
Yeah. Think of it as assured transportation.
Yeah.
So you will rely and you will trust blockchain because all the data from the temperature sensors will be coming and stored on the blockchain. You can always review, you can check it, and you can say, yeah, I trust that the data haven't been. Someone went back and said, okay, I need to correct it. Yeah, we had some.
There's a reason I kept saying temperature sensor, right? Because now you're like, okay,
Exactly.
wait, hold on. I want to coordinate the temperature sensor came in along with this thing was at that point, right? So you got to have IoT devices and blockchain merging together, right. And it's going to be in the field on a truck, 5G, right? See where it goes?
All right, and the final use case. This is another beautiful use case. Anyone here from utilities, power utilities? This is a really interesting use case in utilities. So as you know, utilities went on this now long journey, which is kind of has this big name, smart grids and so forth, where you have lots of the information exchange now taking place, probably more in places where it didn't happen before. We have now new, what is called prosumers, new generation of consumers that now also have a generation facilities at their home. You have renewable energy that also generates power, and also you can provide information so you can balance the grid. So, but in essence, what you can think about, there is multiple parties here, there are multiple databases, and then when it comes to one use case is microgrids. This is, I don't know if you look into that, but microgrids is kind of, you can form a small grid of residential consumers that will start generating and consuming electricity that is within that grid. And in order to balance some of those spikes, we can get something from the outside. But microgrid can operate on their own, right? But then you generate electricity, your neighbor consumes your electricity. So how do you do the payments and tracking and all of that? So clearly a good place for the blockchain. That's where utilities are looking into that as well. So anyway, there's a number of things happening. So utilities are quite excited about blockchain and what can you do with the blockchain, including also tracking like renewable energy generation and so forth. So, and then I think that's kind of it.
So why don't we wrap up here? I mean, we're at the bottom of the hour, okay? So, so that's the end of the time. But what we'll do is let's just wrap up what we're doing here, and then we could just run the demo right here. If you guys want to stay, you guys can come up and stay for the demo, okay?
Yeah,
so let's just wrap up. Let's just go through
idea.
this. We went over the market opportunity. Hopefully gave you a good introduction into blockchain, right? To kind of get the gist of it. 101 level of it, right? So if you want to, some of the questions
less confused.
Yeah, I hope you're less confused. If there's more that you want, there are other sessions that went deep into what you were talking about, like how do we do the GDPR and on-premise. There's a whole bunch of use cases in that. You can take a look at those online. Key thing to come away with is that, you know, IoT and blockchain, you could see all the use cases. When you start to put these things together, it really does look like a routing problem across, to us it does anyway, I mean, because that's the lens that we look at things. And that's why Cisco's in this space, and we think we could bring a lot to between IoT and blockchain. So we went over the use cases in there. So next slide. So let's just say if you have questions and stuff later that come up, ask us in the teams. Please take a look at the survey way out on the ends and do the surveys. And if there's anything that we didn't answer, you know, that you were expecting or something like this, come right up here. We're kind of lucky that it's the end of the day. We could just show you the actual demo and answer a few more questions for you. Okay. Anything else?
All right.
Yeah. Continue your education for the self-paced labs and things like that. And
yeah.
Thank you very much. So
Thank
come
you
on
very
over and
much.
see the demo and stick around.
So yeah,
Okay.
so I think it's probably will be a good idea. Maybe you can come over.
Yeah, we'll just keep doing
I'll show
it.
the
And
modules, and
feel
I'm going
free
to
if-
show you the live demo. That will be on the screen. It will come from my phone. So.
Yeah. Cool.
Thank you.
Thank you very much.
Thank you.